Hello guys and welcome back to 5 minutes of channel. In this video I will explain the flowchart regarding the dataset encryption process on ZOS. In 5 minutes, of course. Do you remember dataset encryption? It is part of the pervasive encryption strategy and allows you to protect data residing on disk from being viewed in clear by unauthorized users. And to implement dataset encryption, you don't need changes to your applications. Authorization is based on access to the key label associated with the dataset and used by access methods to encrypt and decrypt the data. Dataset encryption uses the SAF interface to work with RACF, SMS policies, or JCL in order to identify new dataset allocation requests, then to encrypt their contents by specifying encryption key labels associated to the encryption keys to use for encrypt selected datasets. To work with dataset encryption, the encryption key must exist in the ICSF key repository, the VISAM dataset. And you need three types of keys: a master key, a wrapping key, and data key. All these keys work together with the Z-System hardware, such as the CPACF component and the Crypto Express card. But how are they managed? Well, let me start with the Crypto Express card that represents the HCSM of Z-System. In this card, you can have different domains for different LFRs, but remember, you can have only one domain per ZOS LFR. To manage the Crypto Express card, you can use two different tools: the ICSF software and the TKE console. ICSF is a software component included in the base ZOS operating system, and it is used to provide all the cryptographic calls and functions to the applications which need the encryption. It is based on ISPF dialog interface in order to manage the encryption objects. TKE is an hardenized workstation to be used with a strong authentication to load and manage the master key material in a very secure way. In general, ICSF is used to manage operational keys, the data key, and TKE is used to manage master keys. And now we can start with the dataset encryption workflow. The process works with three components: TKE, ICSF, and HSE. For the master keys, you can use the TKE workstation to create 4 different master keys: IIS, DES, RSA, and CC. And this is valid for each LFR, and they are stored into the Crypto Express card. By using ICSF, you can define the operational keys to be used with dataset encryption. These operational keys are stored in the VISAM dataset that could be CKDS for symmetric keys, PKDS for asymmetric keys, and TKDS for token keys. The operational keys can be stored in clear or in encrypted mode if encrypted with a master key. We have also the hardware storage area, and when you IPL your system, a wrapping key will be randomly created and stored in the HSE. The encryption process starts when the system receives the request from the end user to encrypt a new dataset using 3 possible ways following this priority. RACF, by using the DFP segment present into the dataset profile that specify the key label to be used. The second method is by ACS routine of DFSMS components, where you can specify in the data class which key label to use. The last one is by specifying the key label in the JCL used in a batch job. So, specifying the key label, you can find the data key in the VISAM dataset. In this slide, we have the X key label, which is relative to the data key that is an AES key type that is mandatory for the dataset encryption solution. The X data key was encrypted by the master key, so we need to unencrypt it in the Crypto Express card by using the AES master key before it can be used. Then we have the X data key in clear mode and can be used by the CPACF processor. At the same time, the X data key will be encrypted by the wrapping key in a protect mode, creating the new key, F, defined as protected key. That is the encrypted data key form of the X key. And this new F key will be stored in the ICSF address space, so it can be used for the future needs in creating more encrypted data for dataset encryption. Because we will directly use this key in the ICSF address space and no need to start again the full process. Now we want to encrypt the data, so the encryption will work in the CPACF, and the encrypted data key will go to the CPACF, and with the wrapping key, we can unencrypt the data key. Now we have the data key in clear, and it can be used for the encryption of data. So at the end of the process, we have a new dataset fully encrypted. Thank you for your attention and don't miss the next video on this channel. Bye bye from Luigi.